The next topic is system realization. In 1960s, there is no microcontroller. 1960s, there is no microcontroller. But United States sent a crew to moon. But without doing any simulation, it's not possible to do the practical. We have to check by simulation before doing any practical work. How they did the simulation? All control equations are simulated analog way, analog simulation. We can simulate analog way by using integrator. We can simulate any differential equation. So if you want to simulate, for example, I'm having a system y of s upon x of s, a transfer function equal to k upon, say, 5 upon 3s plus 1. This has to be simulated by using analog circuits, not digital way. Digital, we know how to simulate. We have to digitize the equation, then we have to write program. You can use computers to simulate, but analog, how to simulate? That we are going to see now. If you cross multiply this, you will get 3s y of s plus y of s equal to x of s. That is y of s, if you write in time domain, y of t. S y of s means y dot of t. S means derivative. 1 by s means integration. Y dot of t. 3y dot of t plus y of t equal to x of t. 5x of t. 5x of t. This 5 is there. Therefore, we can write y dot of t differential equation. Y first order differential equation. Y dot of t equal to 5 by 3 x of t minus 1 by 3 y of t. We can simulate this. How to simulate? You know that integrator. If you connect a resistor here and the capacitor in the feedback, it is integrator. It is integrator. If you give any voltage here, that will be integrated and it will be available in the output, but inverted. That is the only difference. So by using integrator, here if you put a sign change here, if you put a sign change, how to put a sign change? Both are R, no gain, only R. If you put like that, integral output in without sign change you will get. Integral output without sign change you will get. So this can be written as symbolically this way. Or you can put integrator sign here. This is integrator. Or you can put this is also equivalent to 1 by s. If you give v in here, integral of v in dt available in the output. If you give v in here, the output is integral of v in dt. By using this, we can simulate this in an analog way. I want to simulate this. For that, I am taking this. How we are obtained this? This is from this transfer function we got this. Y dot equal. Let us assume that y of t is available. Let us assume that y of t is available. We can simulate if y of t is available. Take a summing junction. Take a summing junction. Y of t is available. You need 1 by 3 times 1 by 3 times y of t if you take and subtract. X of t is input. X of t is input 5 by 3 times x of t is given here. These two together, if you add these two together, 5 by 3 times x of t, 1 by 3 times y of t, we are assuming that y of t is available. If you subtract these two, what you will get is y dot of t is available. Y dot of t is available. If you integrate this, what you will get? Y dot of t, if you integrate, you will get y of t. You will get y of t, you will get. So this is analog way of simulation. Analog simulation. Analog simulation of any transfer function. Any transfer function can be converted into this circuit, electrical model. What is the difference between what we have seen in first unit, electrical analogous of mechanical system? We have seen all electrical systems are converted into, all mechanical systems are converted into electrical systems. We did, what is the difference between the two? That is only passive elements there, only passive elements. Here, active element is there. The integrator is active element. This integrator is active element. So here we are converting this into by using active element. So any transfer function can be simulated analog way. That is very much possible. Now in MATLAB, you can, this 1 by s is available. If you want to simulate in MATLAB, take 1 by s, block is available. Then you can simulate this 5 by s. This is constant block is available. So you can give x of s. You can take feedback and give here. The feedback is multiplied by 1 by 3. You will get y of t. So this can be simulated in MATLAB also. Analog simulation you can do in MATLAB also. You have to select 1 by s. This is called realization, system realization. We know the transfer function, but how to realize, how to find a physical system for that? That is called system realization. System realization means getting physical system for given transfer function. Getting physical system for a given transfer function. So how to get physical system? There are 4 methods available. One is called controllable canonical realization, observable canonical realization, cascade form realization, and parallel form realization. First, let us see controllable canonical realization.